everyone, today I'm going to go over using midpoint and distance formula. So let's first go over some vocab. The midpoint is the point that divides a segment into two congruent segments. And a segment bisector is a point, ray, line segment, or plane that intersects the segment at its midpoint. The midpoint of x1, y1, and x2, y2 is x1 plus x2 over 2 for the x-coordinate of the midpoint, and y1 plus y2 over 2 for the y-coordinate of the midpoint. The distance formula states that the distance between x1, y1 and x2, y2 is d equals square root of x1 minus x2 squared plus y1 minus y2 squared. So let's start with some examples. We have the line segment xz, and YA is a ray that is a segment bisector. So that means Y is the midpoint of XZ. So if we know that YZ equals 1 and 5/8, then to find XZ, we can either double that or you can add it to itself. So we know that this side is also 1 and 5/8 centimeters. So I'm just going to multiply by 2. And before we multiply, we have to change this to an improper fraction, so that would be 13 over 8. We can cancel out the 2 and the 8 and get 4, so that would be 13 over 4. So that means xz equals 13 over 4. In the next example, we have the line segment AB, and the line MN is a segment bisector. So that means AM equals MB. AM is 6x minus 4, and that's going to equal 12 minus 2x. In order to solve, we're going to move the variables to one side. So we get 8x minus 4 equals 12, and then move the 4 over. So we get 8x equals 16, and then we get x equals 2. But the problem asks us to find AM, so in order to do that, we're going to plug in 2 for x in for AM. So that'll be 6 times 2 minus 4. So we get 12 minus 4, which is 8. So that means AM equals 8. Okay, so now let's do some midpoint and distance equations. So let's say we want to find the midpoint of AB. So A is at negative 1, 3, and B is at 5, negative 4. So we're going to plug this into the midpoint formula, and if it helps, you can write x1, y1, x2, y2, just so we can kind of keep track of the numbers. So the midpoint would be negative 1 plus 5 over 2, and 3 minus 4 over 2. Then we're going to simplify this. So that would be 4 over 2 and negative 1 over 2. And 4 over 2 is 2, so we get 2 and negative 1/2. And that would be the midpoint of AB. Now if we have find the end point of AB if C is a midpoint. So this time we're given the midpoint and we have to find one of the endpoints. So we have point A at 4, negative 5, and point C at negative 1, negative 2. So in the equation, we usually add the two endpoints together and divide by 2. So this would be x1 and y1. And since we don't have a b, we can call that x2, y2. And we'll just leave that as x2, y2 while we're solving. So we know that x1 plus x2 will have to equal negative 1. We know that this plus this will have to equal this, because that's what happened on number 3. So negative 1 plus 5 divided by 2 gave us the x-coordinate of the midpoint. And since we have the midpoint this time, that means 4 plus x1 over 2 has to equal negative 1. So we're going to be using the x-coordinate of the midpoint for that part. Then for the y value, we're going to use the y's. So we have y1 plus y2 over 2 has to equal negative 2. So if you look at number 3, we have y1 plus y2 over 2, and that gave us our y value. The equation we set up is negative 5 plus y2 over 2 will equal negative 2. And then we're just going to solve for x2 and y2, which will be the coordinates for our b value. So we get 4 plus x2 equals negative 2, so x2 equals negative 6. And then for the y, we'll get negative 5 plus y2 equals negative 4, so y2 equals 1. So that means b is at negative 6, 1. Okay, I erased number 4 and just replaced it with number 5 here, just so we can do another problem that's similar. So we're finding the endpoint again, where C is the midpoint. So we're given that A is at 2, negative 2, and C is at 5, 1. So again, we can call B x2, y2. To set this up, we're going to have 2 plus x2 over 2 equals 5. So that's because we're looking at x1 plus x2 over 2 equals the midpoint. Then for y, that would be negative 2 plus y2 over 2 equals 1. So that's because we have y1 plus y2 over 2, and that'll give us the midpoint. So now to solve, we'll get 2 plus x2 equals 10, so x2 equals 8. And for the y, we'll get negative 2 plus y2 equals 2, and y2 equals 4. So the coordinates would be 8, 4. Okay, and the last part of this section is finding distance. So if we have A is at 5, 2, and B is at negative 3, negative 1, we're going to plug this into the distance formula to solve for the distance. So G will equal 5 minus negative 3 squared plus 2 minus negative 1 squared. 5 plus 3 squared plus 2 plus 1 squared. 5 plus 3 is 8, so we get 8 squared plus 3 squared. And then that's 64 plus 9. So that means the distance is the square root of 43. Okay, so now let's say we have the points J and K. J is at negative 2, negative 3, and K is at 4, negative 5. So if it helps, you can write x1, y1, x2, y2. So the distance would equal negative 2 minus 4 squared plus negative 3 minus negative 5 squared. So that's negative 6 squared plus negative 3 plus 5 squared. So that's 36 plus 2 squared. And 2 squared is 4, so that's 36 plus 4. So we get distance equals square root of 40. And if there are parts of the problem that asks you to determine if the line segments are congruent, all you're going to look at is the distance that you get. So if these two numbers are the same, then that means the lines are congruent. And if they're not, like in this case here, that means they are not congruent. So AB is not congruent to JK. Thank you so much for watching. I hope this video helped you understand finding midpoint and distance. And I will see you in my next video. Bye!